Hi everyone, I am Dr. Sagar Sahu and welcome to Vet Surgery Tips. Today I welcome you to the 8th lecture in the series Orthopedics. We have covered 7 lectures of different topics and this is the 3rd lecture of fracture fixation system. Before this we have covered 2 lectures in fracture fixation system. One is for the external coaptation bandage and the other one is for the external skeletal fixator. Okay, in this class we will be studying the intramedullary fixation device. Mostly we will be dealing with the intramedullary pin and the interlocking nails. Apart from this, we will also cover the orthopedic wear because it is kind of in combination with the intramedullary pin. It is frequently used in combination with the intramedullary pinning. After this, there will be only one fixation system will be remaining, that is the plate and screw. Okay. So today we will be discussing the intramedullary fixation. Before going to the lecture, some formalities. If you are very new to this channel or you are watching for the first time, do check out other videos. I have arranged all those videos in different playlists. Do check them out. Then you can see which playlist is suitable to you and you can enjoy the videos. Okay. And if you are enjoying the content and still not subscribed, please do subscribe to the channel. Okay. And apart from that, in the Facebook, I do post different cases which I get in our veterinary dispensary pictorially with different presentations. And important one is the Instagram. I post all the notes of this particular classes and other classes also in the Instagram, and update regarding videos are also posted in the Instagram. Some interesting case reports are also posted in Instagram. This is the book which I am referring for preparing the lectures of this small animal orthopedics, or you can say simply orthopedics. This is an excellent book. If you want to read further, then you can refer this book. Okay, and don't worry, I will give the link of this particular book in the description, as well as the link to the class notes of this particular class will be provided in the description. Along with the PPT will also be provided, so we don't need to take any notes in this class, simply listen. Okay, so first one is in the intramedullary fixation is the Steinmann pin and K-wire, occasional wire, however you pronounce, simply it is K-wire and Steinmann pins. Regarding the introduction or some basics regarding the Steinmann pin and K-wire, simply they are pins. Okay, Steinmann pin has some particular diameter, we will discuss. So it is basically indicated for diphyseal fracture of humerus, ulna, metacarpal, femur, tibia, metatarsal, but it is contraindicated in case of radius. Okay, it is not used in case of radius because for pin insertion you have to there will be problem regarding the pin insertion because it may interfere with the carpal bones or carpal joint as whole. That is why it is contraindicated in case of radius, but it is indicated in case of ulnar fracture. Okay, it is excellent for bending forces. Here you can see the picture. Here the pin is placed in the intramedullary canal. So when there will be bending forces, it provides excellent stability, but it is not suitable or it is very much susceptible to the rotation. It can easily rotate around the pin, and the axial, when the animal will bear the weight, this type of force in this particular direction is the axial along the axis. So it has poor stability for rotation and axial forces. Okay, due to this reason you have to combine the pin with other fixation systems. Okay, it should be supplemented with other implants like Cerclage, where most commonly it will be using additional support system with the Cerclage wire. Okay, Cerclage wire is also having some advantage and disadvantage. We'll see. It can also be combined with the external fixator. I have told you tie-in configuration. Okay, if you have not watched the external skeletal fixator video, do check the link in the description. Okay, in that particular case, IM pin as well as the ESF can be used, and it also can be combined with the plate. Okay, now coming to the equipments, mostly the important one is the pin. Okay, so the pin are of different types based on some different criteria. Like first point, suppose according to the points, it has 2 types of pins. One is chisel point, this is chisel point, and this is trocar point. Chisel point is mostly used for cortical bone, while the trocar point is mostly used for cancellous bone, penetrating through the cancellous bone, but very commonly in orthopedics the trocar point is used rather than the chisel point for both cortical and mostly we will be penetrating through the You see here, when you will be penetrating the bone, here we will be penetrating here, then the canal, then in the distal part, proximal distal, mostly you will be penetrating the spongy bones, okay, the cancellous bones. So trocar point is very commonly used. You don't need any cortical bone penetration, okay, that is why mostly the trocar point is used, or very commonly used trocar point. Now the point design, according to the point design, it can be single armed or double armed, or you can say single trocar if the point is trocar, single trocar, double trocar. Here you see, this is single trocar, okay, only one side there is trocar. This is double trocar or double armed, okay, double trocar. Next, threading, I have discussed in the ESF also. Threading, it can be end threaded and can be center threaded. This is end threading, these two are end threaded, this is centrally threaded. Mostly the central thread is used in ESF, okay, when you will be using the bilateral uniplanar or bilateral biplanar, all those things. End threaded are used in unilateral uniplanar. I have discussed vividly the external skeletal fixator, okay, so do check out that link, okay. Here it is not of much importance, okay. So next, profiling. I have discussed profiling. For you, just refreshing what is profiling. So you see here, you see, okay, this is the diameter of smooth section. If you look at the diameter of the corrugated or threaded section, it is smaller, comparatively smaller. This is known as negative profiling. Negative profiling. Negative profiling. If this diameter of the smooth section and the diameter of the corrugated or you can say threaded section is same, then it is known as positive profile. Positive profile. The disadvantage of negative profile is that what will happen if any force is applied this in a threaded area, as this diameter is less, there is every chance it may break at this particular point, okay. But this is not in case of positive profile. So positive profile is more common than the negative profile, or it is more desirable than the negative profile. Yeah, this is positive and negative profile, okay. Remember, according to point, chisel and trocar, most commonly trocar is used. Point design, it can be single armed or double armed, or you can say single trocar and double trocar, both sides. Threaded, end threaded, center threaded. Mostly in intermedullary pinning, you will be using end threaded or smooth pins. You see, these are smooth pins. They are smooth pins, but these are threaded pins. Okay. Profiling, positive and negative. Most commonly, the positive profile is used. So you can say positive profile, end threaded, single trocar or maybe double trocar pins are most commonly used in a veterinary practice. Okay, these are Steinmann pins. Regarding the diameter, the Steinmann pin comes from the diameter 1.6 mm to 6.5 mm. This particular diameter, okay, this diameter is 1.6 to 6.5 mm variation, and this length may vary according to your requirement. You can contact your dealer to supply particular length of the pin, whether the single armed or double armed. So this is basically the Steinmann pin. Next, K-wire. K-wire is similar to the Steinmann pin, only the diameter is less. Here it is the 0.9 mm to 1.5 mm. So it can be smooth, it can be threaded. Okay, it can be end threaded or it can be fully threaded. Okay, like this. These are K wires. It can be single armed. Here it is single armed. It can be double armed. Here you can see it can be double armed. Okay, just like the Steinmann pin, it can be classified. Okay, mostly the K wires are trocar pointed, but it can also be chisel pointed. Next, what are the principles used in intramedullary pinning, or you can say Steinmann pin most commonly? So the principles are, first is the pin size selection. How to select the mostly the diameter of pin. Okay, not the length. Length it varies. Okay, but the diameter is very important. So if you are combining with Cerclage wire, which is most common thing, okay, Cerclage wire, the diameter should be 60 to 70% of intramedullary canal. If you are using with the external fixator, 50 to 60% of intramedullary canal. If you are using with a plate, 40 to 50% of intramedullary canal. Suppose the diameter is 8 mm. The diameter of the bone is taken as thinnest point, okay, like here, thinnest point, not here. it is too big, or here it may be too big, it is taken as thinnest point, then the value is calculated, or you can take several values, okay, 2 to 3 values, then take an average, okay, whatever you can do. But you can see in the radiograph that where it is narrowest, then you can take the measurement of the bone diameter. Suppose the bone diameter is medullary canal diameter is 8 mm. Okay, so if you are using Cerclage wire, it will be ranging from the 4.8 mm to 5.6 mm. In between that, you can use a 5 mm pin on an average. If you are using with external fixator, then 4 mm to 4.8 mm. Okay, you can use 4 mm. For 40 to 50% for a plate, you can use 3.2 mm to 4 mm. You can use of 3.5 mm pin. Okay, like that you have to calculate the pin size. Okay. So then the span the length of the bone with the EIM pin, it simply means that the entire pin should length of the pin should be along the length of this particular bone. Okay, it should be like this. It should not be, the pin should not be placed like this up to half ended or some portion, or here it is like this. Okay, it should not be like this. The entire length of the bone should be span with the pin, or the pin should span the entire length of the bone. This is the second principle. Next, regarding the pin insertion, it can be retrograde or normograde, particularly for humerus and femur. For humerus and femur, you can insert the pin retrograde or normograde, but for tibia, it is always normograde. Always advised you should do normograde. So what is the retrograde and normograde? I have already discussed this particular thing in the first class itself, but for this sake of this class, so what is the normograde printing? In normograde printing, you will insert the pin from one end, it will be inserted like this, then it will cross the fracture area, then it will be seated in the other end, or simply you will insert from proximal end, will go through the fracture line, then it will be seated at the distal end. This is basically the normograde. Okay, here we see normograde. What is retrograde? First you have to insert the pin in the proximal segment, take it out. Okay, the pin will be in this level, then reduce the fracture, then insert in the distal segment. This is retrograde pinning. Okay, sometimes if you are using smooth ended pin, one end or single arm pin, one ended trocar, then other end with smooth. First you will be drilling to trocar end. When it will be coming out, simply take the pin out, then rotate the pin, then again insert with the smooth end, it will come out, here it will be smooth end, and the other trocar end, it can be inserted to the distal segment. Okay, then it will be sitting at the distal metaphysis. Okay, this can be used for single armed pin. If it is double armed or double trocared pin, then it is not a problem. Simply insert in the proximal segment, then reduce the fracture, then in the distal segment. Okay, so this is basically the principles regarding the intramedullary pinning. Another one is there should not be any joint interference. The joints above the joint above and joint below, it should be freely movable. Okay, if you are not moving freely, there might be some interference by the pin, which is not good. Okay, so these are the principles which will not change. Okay, other things may change, some techniques may change, some applications, but these principles will be same. Next, the application. So first is, you will decide regarding the pin, the size of the pin, or most accurately the diameter of the pin you will be using, and what are the additional fixation system you will be using. Most commonly the wire is used. Okay, and also you can apply the plate also. Nowadays some research articles are coming regarding the plate. Although in humans there is extensive research, but nowadays in veterinary also they are doing some things. So the next is the aseptic preparation. Obviously for any surgery, aseptic preparation. Then reduce the fracture. I have discussed vividly regarding the fracture reduction in the 4th lecture. I will give the link of the playlist in the description, do check. Next, place the pin, whether the normograde or retrograde, whatever. Next, check the pin insertion, how much pin you have inserted. See, if there is radiograph, it is easy. Okay, you can see that how much length the pin has migrated, or pin has been inserted to a particular length. Okay, you can ascertain from radiograph. Okay, but suppose there isn't any radiograph, how to ascertain? What you have to do in that particular case, suppose this is the pin and this particular length you have decided to insert. Take another pin of same particular length. Okay, this will be the reference pin. This will be the reference pin. Now you have drilled the pin. Okay, now you have drilled the pin and it has seat, or the pin has been sitting in the distal metaphysis. You can feel that when the bone will be penetrating to the distal metaphysis. Now you are confused that how much it has been inserted. So what you will do, take this reference pin, suppose this is not visible. Okay, so we will put the pin end to end. Okay, like this we will put the pin. Now this pin end will tell you where the inside the pin, or the pin which has been inside the intramedullary canal, to which extent it is inside, it can be ascertained by this reference pin. Okay, in this way, suppose you are doing in field where you don't have any radiography facilities, maybe the radiography facility will be far away. Okay, so in that particular cases, you can use a reference pin to know that to what extent this intramedullary pin has been inserted. It is very important, so that if it will be inserted furthermore, then it can interfere with the stifle joint here. This is femur bone, this is coxofemoral joint, this is stifle joint. Okay, so it can hinder with the stifle joint. For that, the reference pin can be used where the radiography facility is not available. Okay, next you have to check the joint interference. Move the joint above and below, it should be freely movable. Next, if you are doing some additional fixation, mostly the cerclage wearing, we will discuss cerclage wearing, don't worry. So these can be put after the pin insertion. Next, cut the excess pin. During cutting, there is something. So suppose here is the skin interface and this particular part is outside. So you have to, with your thumb or some fingers, you have to push some soft tissue towards ventral side. Towards ventral side you will push and you will cut here. Okay, after releasing, the skin will be just above the pin and will cover the pin. So this is basically the guideline or criteria to cut the excess pin. So this is basically the application of intramedullary pin. Next, you have heard of some terms like stack pinning or cross pinning, dynamic cross pinning. Okay, what are that? Stack pinning, cross pinning, dynamic cross pinning, you might have heard. So what is stack pinning? So what will happen? Listen carefully. Suppose I have used a single pin here. Suppose I have used a single pin here. Suppose here. Okay. So this is the single pin which I have used. What will happen? This is this particular area. Here you can see that this is pin and bone interface. Pin and bone interface. What will happen? There will be micro motion between this particular pin and the bone. So with time, when there will be substantial micro motion, daily micro motion, what will happen? This pin will get loosed. Okay, this pin will loosen and it may migrate further. So what someone thought of, who might have done this research. So what he or she, whoever, did that instead of using a single pin, he or she might have used different pins of smaller caliber or smaller diameter. Suppose you have used a 4 mm diameter pin. Okay, so what you can do, you can use 1.5 mm or 2 mm 2 pins or 1.5 mm 3 pins. Okay, so what you will do, you will do the stack means aggregating. So you will do 3 pins inside the intramedullary canal, like here. You can say 1, 2, 3 pins. This is stack pinning. What will happen? There will be multiple bone, the bone and a pin interface. There will be multiple pin and bone interface. What will happen? The micro motion will be distributed. When the micro motion will be distributed, there will be less chance of pin migration. Okay, so this is the basic principle behind the stack pinning, nothing else. Simply pinning, only you have to add more pins of smaller caliber or smaller diameter. Okay, Now the cross pinning, what is cross pinning? So in case of cross pinning, it is mostly used for fascial fractures or metaphyseal fracture. Metaphyseal. But you might have heard supracondylar fractures. Okay, for those the cross pinning can be used. Here mostly wires are used. K wires are used. K wires. What we will do? There will be two wire placement. Suppose this is the medial side. This will be lateral side. So this is the medial pin, medial wire. This will be the lateral wire. So you have to drill the medial wire from the medial side, then it will cross like this to the lateral side. You see this trocar will be just outside the opposite cortex or the lateral cortex, just outside. It should not be too much outside or more, otherwise it will interfere with the soft tissues. Okay. Similarly, the lateral pin will be inserted from the lateral side, lateral condyle, then it will move through like this, and it will be on the medial cortex of opposite side. Okay, medial cortex, and it will be just outside. The trocar will be just outside the cortex. Okay, and another thing you have to remember, this crossing, this particular crossover, it should not be at the fracture line. It should be above the fracture line. Okay. So this is basically cross pinning. After the insertion, you have to, this particular wire will be bent towards you. Okay, this is 3D, not 3D structure, towards bend 90 degree, then it will be cut. Okay, so this is basically cross pinning. Here you can see cross pinning. Next, some scholars thought that okay, this might cause problem because these are pointed structures and this might injure some soft tissue in long run. So what they did? They thought of dynamic cross pinning. Okay, dynamic cross pinning. What is dynamic cross pinning? In this particular case, similarly the two wires will be used, but you see here drilling was from the medial to the lateral or opposite, like from lateral to medial. Here what they did, here the pin was inserted from the distal side. This is distal side. Here the pin or the wire, K wire is also pin. Okay, so the K wires will be inserted like this. Inserted like this from this side, from proximal side, through this canal, through this intramedullary canal, or if it is just above the condyle, then just above the condyle. Like this, it will be inserted. Okay, in cross fashion. Now these two wires will be slightly bent and will be pushed inside this intramedullary canal. Okay, understood how this is? You will insert these two pins like this. Okay, like this. Then you have to simply insert it inside the bone. Insert the intramedullary canal of proximal segment. This is proximal, this is distal segment. See how it looks. It will look like this. Okay, this will be the pin. This will be the lateral pin. This is the medial pin. If it is medial side, and this is lateral side. Okay, like this, and you have to bend 90 degree and cut the excess pin. So how it is stabilized? Here you can say that when it will be bending forces be applied, this particular, when it will be placed inside the cortex, it will resist the bending. But here how it will do? So suppose there will be some bending forces like this. Suppose the bending force is in this direction, like this. Then this particular pin which is inside the medullary canal will resist. Suppose there is bending force from this side, then this particular pin will resist. Okay, understood how it will resist? That is the name dynamic cross pinning. Okay, both the pin will work dynamically. So this is dynamic cross pinning, and here also the crossover should be just above the fracture line, not exactly on the fracture line. So this is basically the stack pinning, cross pinning, and the dynamic cross pinning. I hope now you got the concept regarding this. So you see many times when we heard some terms like dynamic cross pinning or cross pinning, if you do not know the concept, we may get worried or we might think that it may be some bigger thing. Okay, it's not like that. Sometimes when you understand the concept, it's like, no, I still know these things. And regarding the orthopedics, although teaching is very easy, okay, I know that I am teaching this, it is very easy, but it is more like fine art. More you do, you will get expertise. Okay, it may not be possible in my part that I will be doing all the surgeries. Okay, I might not be the expert in this also, but thing is I can teach, so I am teaching. But you should know all these concepts. My aim is should know all the concept of orthopedics, so that when if you are interested in orthopedics, I am not that much interested in orthopedics, so you will not be afraid of these concepts. You will be knowing all the concepts, all the principles, so that when you will be doing your orthopedic surgery, you can be a better orthopedic surgeon. Okay. Okay. Now too much of a lecture of other things. Now the postoperative care of intramedullary pinning. You know that for any surgery of orthopedics, you need analgesia and activity restriction. It should be evaluated in every 6 weeks by taking radiographs. There is a complication, seroma formation of the, I told you it will be caught just below the soft tissue. Okay, so in that particular area you may find seroma formation. Owner might complain regarding the seroma formation, but it is not a problem. Once the pin will be removed, the seroma formation will be subsiding. Okay, means regarding the pin removal, the KOS and the cross pins are generally not removed unless and until it causes problem. But Steinman pin, it is removed under sedation and local anesthesia. Simply give an incision over the pin, which is the proximal side. Let me show you. Okay, here you see. Give sedation and give local anesthesia around here. You have got the pin here. Okay, give the local anesthesia here. Give a small nick through the manual with artery forceps. Simply dissect the area. Hold the pin with the pliers and remove it. Okay, this is the pin removal. Next is the interlocking nail. So interlocking nail, in the previous class I told you there are 3 fixation systems which are very rigid. Okay, it is resistive of all the forces. First one is the ESF, I have already covered. Second one is the interlocking nail, very strong. Third one is the plate. We will discuss plate in the next class. So this is the interlocking nail. Simply it is an intramedullary fixation type. Intramedullary nail fixed with screws or bolts. It comes with locking bolts or screws can also be used. It resists all forces acting on the fracture. Very rigid fracture. Okay, fracture fixation system, very rigid. So the indications are mid-diaphyseal fracture of a humerus femur tibia, not the metacarpal or metatarsal, just like the intramedullary pin. It is contraindicated for radius, just like the intramedullary pin. It is contraindicated because it will interfere with the carpal joint for insertion. There should be enough cortical bone proximal and distal to the fracture line. Ideally, it should be 2 cm. Suppose this is a fracture, there should be at least 2 cm of cortical bone for insertion of screws. Okay, for insertion of screws, especially if you are using interlocking nail. These are some introduction. Let us go to our main equipments. It might slightly get complicated. Pay attention. So there are 3 parts of this particular set. First one is the nail, which we are studying. Nail. Next, the extension piece, nail, drill guide, jig. Let me show you in this radiograph. This picture. See this stainless steel structure here, here to here. This one is the nail. This particular portion is the nail. To nail this green portion along with this particular portion, this portion is the extension piece, and this section, this one which is attached to the extension piece, is the drill guide jig. Okay, drill guide jig. I will explain what are the functions. First, let us see what are the sizes in veterinary cases. It is most commonly 6 mm, 7 mm and 8 mm. You see the pin is finished at 6.5 mm maximum, but it starts from 6 mm. Okay, we will discuss how the size is selected. 6 mm, 7 mm and 8 mm. It is kind of thick. The screw hole, you will find 4 screw holes, proximally 2 screw holes and distally 2 screw holes. Okay, you see here, you can see also 2 screws here, 2 screws here. Okay, 4 screw holes. It also comes with 3 screw holes, but most commonly 4 screw holes. So the distal point, it can be blunt. Here it is blunt, or it can be trocar, having a trocar. And this particular interlocking pin, when it is viewed from dorsally here, okay, like this, it has internally threads, like these threads, to which this extension piece will get attached. Okay, extension piece will attach, then only you can insert through the medullary canal. Okay, because this particular length will be entirely inside the bone. Okay, so it will be, see, for if you using intramedullary pin, it is like this. It is very long. You can use a drill machine and you can guide this one. But in nail, usually the length is the length of the bone. So it will be very difficult to insert into the bone. So for this extension piece is used. This particular extension piece. When we will discuss the application, we will understand how it works. Okay, so these are basically the equipment. Next, the principles. First principle is use the largest nail. Suppose this is, you see this particular, this is the radiograph and this here is the fracture. You see the nail. Nail almost entirely covers the intramedullary cavity, almost. So you have to use largest nail that can fit into the intramedullary canal. Okay, next is the span the length of the bone. You see the nail length. It is entirely inside the bone, entirely inside the bone. Its length is nearly equal to the length of the bone, unlike the intramedullary or Steinman pin. Steinman is comparatively more longer. Okay, here the pin will reside inside the intramedullary canal completely. Okay, and also it is not removed after the surgery. When the bone heals, it is not usually removed. Though you can remove, but it is usually not removed. Next, the pre-assemble the nail, extension piece and jig to check. What does this mean? Here let me show you. So before the surgery, you have decided that diameter of the nail. First you will decide the diameter of the nail. Next you will decide the length of the nail. These are basically on the basis of radiographic evaluation. So what we will do, you have, suppose you have taken a 6 mm nail, okay, diameter, and you have selected that 180 mm length of the nail will be used. Suppose now this is 180 mm nail and it is having 6 mm internal diameter. Okay, now you have done. Now what you will do, you have to pre-assemble. Before the surgery you have to pre-assemble. Why? You see the proximal two holes, these proximal two holes of this drill guide jig is kind of fixed. Here it will be attaching the extension piece, and through this the screws can be fit into these proximal two holes. But what about the distal hole? Suppose it is not 180 mm, 160 mm, nail will be at this level. So we have to see which holes. Here you see multiple holes, it is having some distance, 155 mm, 135 mm, 147 mm, 160 mm, 170 mm, different nail length, it has different positions. Okay, so you have to first pre-assemble and check at which positions the screws will be inserted. Okay, proximal 2 is fixed, distal 2 you have to decide the which holes, you have to mark these holes. Understood why the pre-assemble is necessary before inserting the interlocking nail. Now we have decided, suppose we have decided these two holes will be used for distal and these two holes will be used for the proximal, because once the nail is inside the intramedullary canal, it is blind, you cannot see the screw holes. Okay, so if you will decide these particular holes in which you will be drilling, then when you will be, suppose this is inside the bone, it is covered, and you will start drilling through the bone, it will automatically go into the holes. Okay, that is why you need pre-assembly. So before the surgery, pre-assemble and check which holes through which you will be drilling, and it will go into the holes in the nail and you will fix the screw. Okay, this is the pre-assemble. Next is the rimming. Okay, you have to rim the bone. Rimming, it means simply make a hole through the canal. Rimming. So this rimming can be done normograde or retrograde. You can do normograde or retrograde. Okay, and for rimming, the principle is the rimmer diameter, it should be 0.5 to 1.5 mm greater than the nail diameter. Suppose you have using 6 mm nail, then the diameter of the rimmer should be 7.5 mm. And regarding the rimming, you should not directly go for 7.5 mm rimmer. You should start with 5 mm, then 6.5. Progressively you have to increase. Okay, and if you do not have a rimmer, then you can also use Steinman pin for rimming. Okay, so this is basically rim the medullary canal just before inserting the nail. Next, normograde insertion. Usually the interlocking nails are inserted normograde, no retrograde insertion. Then the nail position, holes are 2 cm away. You see these holes, it should be minimum 2 cm away. I explained that minimum 2 cm cortical bones are required for insertion of the screws. Okay, here it is the fracture. You can say here it is the fracture. So there is a lot more gap. It should be minimum 2 cm. Now these are the basic principles. Okay. Next, application. First I told you select the nail. Largest nail will be selected. Select the nail. Next, rimming. I told you have to do the rimming. Normal grade or retrograde, it should be 1.5 mm greater than the nail diameter. Extension piece is attached, then you will attach the extension piece to the nail. Nail will be inserted. Okay, this nail will be inserted. You see, this is the extension piece. This is the extension piece. Okay, this particular handle with handle is the extension piece. Then it will be inserted. Okay, when here the drill jig will not be there. Up to this point, drill jig will not be there. So after insertion, suppose it got stuck or there is some problem. Here you can see a hole to which flat like structure. Although different company has different models. For basic, here it will be like this, a flat structure to which you can hammer down and the nail can go inside. Okay. So now in this particular animal, the nail is already inside. After that, you have to insert the drill guide jig. Okay, this drill guide jig will be attached. It has very fixed grooves and knots. It will be attached. After attaching, you have already marked which holes, like this here to the proximal holes and these distal 2 holes. You usually start with the distal one because it is more difficult to insert. So start with the most distal one. Okay. Now, what are the steps in screw placement, or you can also use bolts. It comes with the, in case of bolts, you see the tapping will be avoided. It is self tapping. Okay. So we'll discuss this how to use a screw. Okay, in the next class when we will discuss in plate and screw. Just for basics you should in this for this class. Okay. So what first is protection sleeve. You see here this bluish coloration. Okay, it's protection sleeve. So this is protection sleeve, this bluish. Next to the protection sleeve, you can see a greenish one. Okay, this is the drill guide. Drill guide. This is protection sleeve. Protection sleeve. This is drill guide. Drill guide. Through which drilling will be done. This is what you are seeing. Here you can see here the cranial portion, or you can say the front portion of this drill guide. Drilling machine. The part of the drilling machine which drills through is the drill bit. Drill bit. Drill bit is used for drilling. Drill bit. Here will be the bone. Okay. Suppose this is tibial bone. Here will be the bone. Okay. Through this you need to drill. So it is drilled by drill bit. The first one the protection sleeve, the bluish one the protection sleeve, into which the drill guide will be inserted. Suppose you are using 3.5 mm. Okay, screw. For that there is a chart. Okay, in the next class, don't worry, I will discuss that. What are the, when you are using particular screw, what will be the size of drill bit, what will be the size of tap, all those things we will discuss in a chart. Don't worry. Next, after inserting the drill guide, through the drill guide you have to make a hole through with the help of a drill bit. Now next you have to measure the depth gauge. You have to, here will be depth gauge will be inserted. It will measure this particular length. By this length you will select the screw length. Suppose you are using 3.5 mm screw. 3.5 screw. Suppose this is screw. This particular screw diameter is 3.5 mm. That means it is a 3.5 mm screw. But this length can vary depending on the thickness of this particular bone. Okay. So this length is detected or measured by depth gauge. After you measure depth gauge, suppose it came 18 mm, 20 mm, whatever, then you have to select 3.5 mm screw with having 20 mm length. Okay, like that. Next you have to do the tapping. What happens in tapping? Suppose this is bone. Suppose this is bone. You have drilled a hole. Suppose this is the hole you have drilled. Tapping will give the threads. Okay, then you can apply the screw. That for before the applying, it is tapping. There are some screws which are self tapping. You don't need a tapper. Okay, so this is tapping, then the screw will be placed. Don't worry, next we'll discuss these screws, that what is the diameter of the screw, how it is decided, what are self tapering screws, all those will be discussed. Don't worry. So for here, just remember, first you have to insert the protection sleeve, then the drill light, then drill bit will make a hole, then measure the depth, select the screw, then they do the tapping, and then they place the screw. If it is a self tapering screw or bolt is used, sometimes with the nail, manufacturing company provides its bolts. So if bolt is used, you don't need a tapping, it is self tapping, it will do the self tap. It will make its own threads and it will get seated. Next, I told you the most distal one is first inserted, then other things are inserted. Once this one is inserted, rest is a piece of cake. Okay, simply put a protection sleeve, then drill sleeve, do the hole through the drill bit, then place a screw. That's it. Okay, but it is a kind of time consuming process, but it is one of the rigid fixation system. So when it is something more powerful, it takes time. Okay, so this is basically application of the interlocking nail. Regarding the post-op, I told you every orthopedic cases you need analgesia under activity restriction. It should be evaluated every 6 weeks. Normally it is left in that particular place after healing. If it causes some complication, then it is removed, but it is only removed under general anesthesia, not under sedation. Okay, so this is interlocking nail. Next, orthopedic wear. Orthopedic wear is not under the intramedullary fixation, but it is commonly used in combination with the pins. That is what we are discussing here. Orthopedic wear. Now, orthopedic wearing can be of cerclage wear or hemicirclage. I have discussed this in the first class when I was discussing different types of wear. So this is cerclage wear, means you are putting the wear around the circumference of the bone. Hemicirclage, you have made a pre-drilled hole through which you are doing the wearing. This is hemicirclage. This is cerclage wearing. Next is hemicirclage wearing. Hemicirclage wearing is not so popular. More popular is the cerclage wearing, especially for long bone fractures. Next, what are the criteria to use wear? First, the length of the fracture line, it should be minimum of 2 times the diameter of the diaphysis at the level of fracture line. It means this is the length of the fracture. This particular length of fracture, it should be more than 2 times the length of the fracture line. Okay, this, suppose you have taken a diameter of this bone, it should be 2 times. Suppose the diameter is 8 mm, the fracture line minimum should be 16 mm. Then only you can use wear. Most commonly it is used for long oblique fracture and spiral fracture. It is contraindicated in case of short oblique and transverse fracture. In those two cases, orthopedic wear is not used. Fracture must be anatomically reduced. Before placing wear, you need a fracture to be anatomically reduced. After that, you can use the wear. You see, I have already discussed how to reduce oblique fracture in the fracture reduction, lecture number 4. Okay, in the playlist, do check that out. Next, orthopedic wear, it comes from 16 gauge to 30 gauge, 16 gauge to 30 gauge. But in veterinary, 18 to 22 most commonly used, 18, 20, 22. Okay. Next, some principles. You see here, I will not be discussing the application because it is not that complicated. Simply you have to use the wear passer, okay, around the bone, then pass the wear. That's it. Okay. But here the important one is the principles and also the knot. Okay, we will discuss the knot, how to put the knot. So the principles are: for large dogs you need 18 gauge orthopedic wear, for small dogs you need 22 gauge or 20 gauge. Okay. Next, place 2 to 3 cerclage wears per fracture line. Okay, here you can see this is fracture line. You need 2 to 3, minimum 2 to 3 cerclage wear. Place wears perpendicular to the long axis. This is the long axis of bone. This wear should be perpendicular to the long axis of the bone. Next, space between the wears, it should be half to 1 bone diameter. Suppose this bone diameter is 8 mm. Suppose it is 8 mm. The spaces between it will be 4 mm to 8 mm. 4 mm to 8 mm. the space between these two. Okay. Next, K-wires can be used to prevent slippage. Suppose you might think that it might slip, you can use a K-wire. Here a K-wire is used. Here is one end, here is another end, and you can use wire, one loop above the wire, one loop below the wire, so that it will not slip. K-wire. Okay, this is orthopedic wire. This one is the K-wire. K-wire you have used. Then one loop, orthopedic wire loop above the K-wire and one below the K-wire. Okay, it can further strengthen. Support with additional impulse Cerclage wiring is not used singly. It is most commonly used in combination with the IM pin. It can also be used in combination with the ESF as well as bone plate. Okay. Single lap versus double lap. You see here, these are mostly single laps. You can use a double wrap. When you will be using double wrap, then you may expect some degree of compression as well. In single lap, you may not have certain degree of compression, although might have some minor degree of compression at the fracture site. But when you will be using this double wrap, then it might provide a significant amount of compression at the fracture line. These are basically principles of wiring. Now the most important one is how to place a knot or method of tightening. There are two methods. One is a twist method, twist. Another one is the loop, twist and loop. So what happens in twist? First, using your hand, okay, first tighten like this, you have to tighten. Then using your hand, make 2 to 3 twists. Okay, usually it is said that you have to make 3 twists by your hand. While after making, you can see here 3, 1, 2, 3. Okay, after that you can use a needle holder, most importantly orthopedic plier. You can use a plier to further tighten. Okay, like this you have to tighten. After tightening, simply cut the wire. You can cut the wire 3 mm from the initial site, 3 mm, this length should be 3 mm, or you can cut 5 to 7 mm from the initial site, and you have to rotate to like this. Suppose you are using here, like you are using in clockwise, like this you are doing. After that, this particular will be clockwise rotated, this particular knot. Okay, this will be clockwise rotated. Now some description, if you can watch, simply what I told is written here. Next, loop Cerclage. Here what you have to do, first you have to make a loop before inserting the orthopedic wire. You have made this loop. See how it is made. This loop, it has been made. Then insert the wire. Then this is the free end. Okay, this is the loop end. Or you can say this is the eye. This is the free end. So you have to insert the free end through the eye like this. Then you have to use the wire tightener. Wire tightener. This is the instrument which is used. Wire tightener. Using the wire tightener, you have to tighten the wire like this. There is a mechanism in this particular wire tightener by which the wire can be tightened. After the wire tightener, simply bend this particular free end like this. You have to bend. See how it is bent. Okay, you have to bend. Okay, after bending, simply cut the wire and push this particular wire towards the bone. Free end, the cut end, push towards the bone. This is basically two methods. That is the twist method of tightening and the loop method of tightening. Whatever you may want, you may follow. Okay, so this is written. You can take a screenshot also if you are commonly using the wiring. Next, so next is the post-operative. Just like the interlocking nail, orthopedic wires are not removed even after healing. Okay, the pins will be removed, but the wire will be in the place unless and until it causes a problem. Because you see, there will be fibrosis. You see, suppose this particular knot is here. Around this particular knot or twist, whatever you can say, there will be fibrous cap formation. Okay, when there will be fibrous cap formation, it will not cause much of problem. Okay, that is why it is not removed even after the surgery. So post-operative analgesia, every orthopedic activity restriction every 6 weeks you have to evaluate radiographically. Orthopedic wires are left in place after bone healing. It is not usually removed unless and until it causes problem. For that you have to incise and remove. Next, you have heard about tension band wiring. Tension band wiring. What is that? Tension band wiring. So for this tension band wearing, the most appropriate fracture or the fracture for which the tension band wearing is used is avulsion fracture. Avulsion fracture is basically a fracture of that particular segment to which a tendon is attached. Most common is the olecranon fracture. Okay, olecranon in the anterior the forelimb, and also the tibial crest where two ligament attached. The tibial crest avulsion fracture. Those are avulsion fracture. For those tension band wearing is used. Here the purpose is to convert the destructive tensile forces into the compressive forces. How it is done? Suppose this is the avulsion fracture. It is a trochanteric fracture of femur. So this is avulsion fracture. What you have to do? First, you have to drill 2 K wires. Okay, here the K wires are used. You have to drill 2 K wires. It should be perpendicular to the fracture line, perpendicular to the fracture line, perpendicular to the fracture line, and parallel to each other. Parallel to the each other. You have to drill 2 K wires perpendicular to the fracture line and parallel to each other. Okay, like this here you have shown, and the distal end it should be seated at the opposite cortex. You see it is seated at the opposite cortex, and you can see that the trocar point is just above the cortex, just outside the cortex to be more appropriate. After that, you have to drill a hole distal to the fracture. The distance between this fracture line and the K wire it should be similar. Okay, this hole, fracture line and the K wire it should have a similar length. Okay, suppose this is 8 mm, so this will be 8 mm also. Okay, now you have drilled the hole here, then use a K wire like this, insert the K wire, then cross it like this, just take above these K wires and put a knot. Regarding the placement of knot, okay, regarding the placement of knot, it should not be placed at the curved section. Like you see here the orthopedic wire there, this is the curved section, this is curved section, here it will be curved section, it will be curved. So it should be placed, the knot should be placed in the flat sections. Here these are flat sections. In this flat section the knot should be placed. Okay, on the curved section it should be avoided. So now you have put a tension band. Tension band is now complete. What is a tension band? Suppose this ligament is pulled. Suppose this ligament will be pulled. When it will be pulled, it will try to come outside, but this particular tension band will oppose this movement and provide the counter force like this. So this counter force will cause further compression. So this is the conversion of destructive tensile process. This is destructive tensile process, but this tension band will make sure that it will be converted to the compressive forces. Okay, to compressive forces. This is basically the tension band wearing, most commonly used for the avulsion fracture to which a tendon or ligament is attached. Okay, so this is all about the intramedullary fixation and orthopedic wearing. Okay, so if you like this video, please do share among your friends, colleagues and juniors, and next class we will go for the last one, the plate and screw. Okay, so till then, tata, bye bye, take care.